Okay, hello everybody. Compute the Frenice array or TNB frame for this curve at the point t, or time, equals pi over 4. Okay? Why pi over 4? Well, so that this will be easier to do, to plug it in. Okay, so in this case, the curve is a helix. Sort of goes up and up and up and, well, mine sort of is tilted over, but that's just a bad drawing. And at any point in the curve, we're moving along, and there should be a t, an n, and a b. They should all have length 1, and they're all at 90 degrees with respect to each other. So like the n and t are 90 degrees, b and t, b and n. They're all at 90 degrees mutually, sort of filling out three-dimensional space. Okay? And this is at so this point right here is our point gamma of pi over 4, which means evaluate the map gamma. I'm calling it gamma. Evaluate it at t equals pi over 4, and it gives you a point in three-dimensional space, and this is that point. Okay. So that's sort of the cartoon. And now how do we do it? Well, if gamma sends t to cos 2t sine 2t t, then gamma dot, the velocity, is, okay, derivative of cos is sine. So chain rule pulls out a 2. Derivative of sine is cos. Chain rule pulls out a 2. Derivative of t is 1. Gamma double dot, the acceleration, sends t to, okay, derivative of this. Derivative of sine is cos. Chain rule pulls out a 2. Derivative of cos is, wait, did I mess up? Derivative of cosine is negative sine. Okay, so negative. So right from here to here, the derivative of cosine is negative sine. Okay, and the derivative of sine is positive cosine. And that's just something you remember, or you forget, like me. Now, the derivative of cosine is minus sine, and chain rule pulls out a 2. And here the derivative of sine is positive cosine, but I had a minus sign, and so it sticks around. So now I think it should be roughly correct. Derivative of 1 is 0. Okay, good. So this is now our curve, our velocity, our acceleration. Good. Because remember, t is the unit tangent. And it's equal to, well, normalize the velocity. N is the unit normal vector. Normal, it should be normal to the tangential direction. So we could take it to be the acceleration, but the acceleration might not be orthogonal to the velocity. For example, if we're speeding up, then the acceleration is in the direction of velocity. We're going to keep getting faster and faster and faster. But what we do is we take the acceleration and we remove the piece that's in the direction of the velocity by doing this formula, which we know quite well at this point. Okay, and then to get the unit normal, so that it has length 1, this vector n, we have to normalize this whole thing. Okay, and then finally the b is the unit binormal, for lack of a better name, and it's just equal to t cross n. Or in a computer you might type cross, open parenthesis, t, comma, n, end parenthesis. And that sort of evaluates the map cross at the points t, comma, n. Or the vectors t and n. Okay, so Well, that's why we started computing these derivatives. So now let's plug in t equals pi over 4. Okay, so you can see that in all of these things, right away what happens is we're going to multiply it by 2. So pi over 4 times 2 is going to require us to know what is the cosine of pi over 2 and what is the sine of pi over 2 in order to plug in here. Okay, so that we just think back to the unit circle, and a point on the unit circle with angle pi over 2 is this point at top, and that has coordinates cos comma sine, which then must be, from visually, it's 0, the x-coordinate is 0, and the y-coordinate is 1. Okay, so whenever we see a cos, it'll become a 0. Whenever we see a sine, it becomes a 1. Okay, so gamma of that specific t, let's set t equal pi over 4. I don't want to keep writing pi over 4 everywhere. Okay, I'll write pi over 4. Pi over 4. Here we go. The cosine becomes 0. So this becomes a 0, a 1, and a pi over 4. Okay. Gamma dot at the time t equals pi over 4 is what? Well, now this becomes a 1, this becomes a 0, and this stays a 1. So the sine becomes a 1, so I have a negative 2. This becomes a 0, and 2 times 0 is 0. This is obviously stays a 1. Okay. Gamma double dot at pi over 4. So I plug in, and this cosine becomes a 0, so negative 4 times 0 is 0. The sine becomes a 1, so I have a negative 4, and then I have 0. Okay, excellent. So now, what do? Well, we look over here, and we see what our formulas are. So first, normalize the velocity. Okay, so t is equal to normalize the velocity. Well, 1 over the square root of 4 plus 1 is 5. And what is it? Negative 2, 0, 1. So that's t. We found t. We normalized the velocity, dividing it by its length, so that now this thing has length 1. Okay, what's n? So what we have to do is we have to compute these dot products to see how much of the velocity do we need to remove from the acceleration. So let's first compute this dot product. Well, we actually already computed this bottom one. It's 5, right? That was in order to get the length, we took the square root. So really this is going to be gamma double dot minus something divided by 5 times gamma dot. Now what is this thing on the top? It's this dot product. So let's look here. Negative 2 times 0 is 0. 0 times negative 4 is 0. 1 times 0 is 0. And this is a 0. And this is why this problem is wonderful, because the acceleration didn't even need to remove. It was already orthogonal. The acceleration and the velocity, their dot product was 0. They were already orthogonal. So we didn't have to remove any of the velocity because the acceleration had 0 component in the direction of velocity. And so all we have to do now is normalize gamma double dot, because this was just gamma double dot minus 0, this whole thing. Okay, so normalize it. Well, we know gamma double dot is right there. Normalize it, and we just divide by 4. It's pretty clearly going to give a normal vector. 0 minus 1, 0. And that is n. I guess I wrote n equals, that's not right. So n equals normalize all that stuff. Okay, so now I've got t, now I've got n, and now I can do their cross product. B is equal to the cross product of t and n. Well, that's equal to the determinant of this matrix, where I have E1, E2, E3, the unit vectors in the 3 directions. And I put t, which is negative 2, 0, 1. It has this 1 over square root of 5. which, because the determinant is linear in its rows, I can take that outside. It'll just sort of wait. And then I put n down here, so that is 0, minus 1, 0. And now I can compute this. It'll be 1 over the square root of 5 times some vector that's coming out of this determinant. So e1 times 0 minus negative 1. That's going to be 1 e1 plus e2 times 0 minus 0. So none of e2, and then e3 times 2 minus 0. And so this is 1 over root 5 times 1 e1, 0 e2, 2 e3. And there we go. Here's t, here's n, here's b.